Okay. Hi everyone. We are going to see sixth question of day 4 of starter 211. Problem name is tournament rigging minimum. It's the easier level question of cup set. Okay. So question is pretty simple. What we are given is a number n and a number w. Two inputs are given to us. Is that right? Imagine the tournament is going to be happening where winner of the tournament is decided. Winner of the tournament is w. Yes. You have 1 to 2 per n numbers, 1 to 2 per n people we can assume, and winner is w. Your task is to design a tournament matching in such a way w comes out to be the winner. Yes, for these numbers. Let's see an example. I have written this to save a little time. Don't get overwhelmed with this. Okay, so as I said, there's a tournament for 1 to 2 per n people, guys. Yes, and I'm taking an example where w is 1 is the winner. We know these are the participant, is that right? Participant is 1 2 3 4. Yes, so we have to match them. We have to keep a match for them such that 1 comes out to the winner. And how winner can be decided? Winner can be decided in two ways. One, when two people are playing, you can either take maximum of them considering them as winner, or you can take minimum of them considering them as winner. Okay, now there is a small twist here, but let's see. Let's say we want 1 to win. Is that right? We want 1 to win. So if you want 1 to win, here we have to take the minimum only. Maximum, if you take, 1 will not win. So here 1 will be the answer, and here we don't care. Let's say we took 4 itself, right? Now among these two, if you want 1 to win, we definitely want to take minimum only. Is that right? This is what one tree or one tournament we can say. Yes, but here small change that we have to also take care of is upset count. Yes, upset count. What do you mean by upset count? Think about it this way. When 3 and 4 are playing, imagine every single player is very honorable. Like, they will feel upset if they defeat someone who's of lower value than them, right? Like in this, how did 4 won? 4 won by defeating 3. That means 4 will feel upset. Yes, and what we want to do is we have to minimize upset count as much as possible. Minimize upset count. This is what the problem is. You have to have a tournament. You have to display a tournament where upset count is as low as possible. Yes, let's see another case where you don't have 4. What if we take minimum out of them? What if we take 3 itself? Is 3 getting upset here? Answer for that is no. Yes, because 3 has defeated 4. Is that right? 3 might feel proud. Now among these, 1 is the minimum and 1 is the answer. So there are 0 upsets here. Is that right? 0 upsets, and this is what we want to achieve. So for this, the tournament that we have designed, your output will come out to be this. Start with 1, then 3, then 1 2 3 4. And if you see, this is what the output will be, and it is of size 2 per n plus 1 minus 1. This is what we have to return. Okay, and of course there can be multiple possible answers. What we have to return is just one of the possible answers. Yes, great. Now let's take one more example where upset count might not be 0. What if I tell you that w is not 1, it is 2? Let's assume. Yes, if w is 2, let's think what will change here. Yes, what will change? Out of these two, we cannot take 1 now, because if you want 2 to win, we have to take the maximum. That means here upset count became 1. Now here we don't care, we can simply take 3 because we don't want to increase the upset count. Among these, we can simply take 2. Yes, because we want 2 to win. Upset count is 1, and your valid answer will be 2 2 3 1 2 3 4. This is what the answer will be. Is that right? This is one of the possible answers. Many possible answers can be there. You can print any. This is what the question specifies, guys. Yes. Now one question I have. Tell me, if upset count, not upset count. What if I tell you winner was 4? What we could have done here? Yes. If winner has to be 4, what we could have done here? Do you agree? Now we can start thinking in terms of divisions. When we talk in terms of divisions, this can be a standalone division. This can be a standalone division. When if winner is on this side, we only need to worry about upset on this side. Here we can keep on taking minimum until the point they meet. Then we'll see what we have to do. Yes. Now let's focus on the left part first, where winner is not belonging to that part. Here we can take minimum itself. 1 will be there. Here, out of 3 and 4, if you want 4 to win, we have to take 4. Is that right? Now at this point, you have 2, you have 1 and 4. You have to take 4 itself. Yes. That means we are able to see, just worry about the part where winner is there. Try to minimize upsets as less as possible. Yes, and the finally 4 has to be winner, and your output will come out to be as we print the level order, like 4 1 4 1 2 3 4, and we are done. Yes, that means we're able to see if W is the last value, guys. If W is 2 per n value, number of upsets we'll have is 2. Can we say that it is upset 1, upset 2, because both of the times we took maximum value. Yes. Yes. Now try to think of it this way. If we have last level ready, right? If n is 3, let's assume, what are the numbers we're talking about? We are talking about 1 to 2 power 3, which is 8. Yes, let's say we have last level ready, 5 6 7 8. This last level can help you to get to any answer in minimum offset, is that right? Because we are able to see they are identical kind of, is that right? Yes, that means once you have the last level ready, you just need to decide who should be the winner of last level. And we know if winner is 6, let's assume, we only have to minimize upsets in this. That means whether we will take maximum or minimum this side, we have to decide. But on this side, we will definitely take minimum only. Can we say that? Yes. That means here we can simply conclude take minimum get 1, take minimum get 3. Out of these two, if you want 6 to win, you will have to take maximum, and upset count has become 1 in this. Yes, here we'll take minimum only. Now in this case, again, as it's the left part, we'll just take the minimum. On the right, now if you want 6 to win, yes, if you want 6 to win, we can take simply 6 only, right? That means here upset is not increasing. Now among these two, if you want 6 to win, you will say at this point upset has become 2. Yes, that means simple thing to solve this question is first have a list ready. First have a list of 1 to 2 per n ready. What you need to do is just compare two values. Yes, just compare two values, and of course only worry about the part where your W is there. Yes, until W ka part is not there, keep on getting the minimum value. But whenever W comes, you have to take the W itself. And while taking W, suppose if it's the maximum value, you will have to update your upset count by 1. Yes, you will have to update your upset count by 1, and you will be continue doing this. This list will generate this list, is it right? Now continue working on this part. Ignore the left half of the part where winner is not there, and again take the minimum, generate a new list, is that right? Next level tournament. Now among these, you will take 6, but is 6 the minimum? Yes, that means upset count will not change. This is the last second level, is it right? Among this, you will have to take 6. To take 6, you will have to take the maximum. Upset count will be incremented, and lastly 6 will be done. Now imagine like you have a 2D list where 1 2 3 4 list you have. At the last, you'll be just appending it, returning it, and done. Yes, cool. I hope this was intuitive. Thanks, guys.